In this video, we're going to learn about something called an indirect proof. Although it may sound complicated, it really is quite simple a concept to understand. Let's establish the basics first. This might seem completely obvious, but it is extremely important to an indirect proof, so bear with me. Statements are always true or false. If a statement is not true, then it is false. If a statement is not false, then it is true. There are no other alternatives. An indirect proof works something like this. Let's say we are given some information and then asked to prove that A equals B. Using an indirect proof, only once we have proven that the statement A is not equal to B is false, can we say that the statement A equals B is true. For example, if your mom wants you to prove to her that you were doing your homework for the past 2 hours using an indirect proof, the only way you could prove that would be by first proving that the assumption that you were not doing your homework for the past 2 hours is false. Therefore, you had to have been doing your homework for the past 2 hours. If it seems confusing now, don't worry. It will all become clearer when we start going through examples. There are 5 main parts to writing an indirect proof. Number 1. Assume temporarily the negation or the not of what you need to prove. Number 2. Get a conclusion or conclusions based on the assumption. Write it or them in the form of conclusion semicolon reason. And this reason would be like a postulate or theorem or given that justifies your conclusion. Number 3, get a contradiction, and this would be a contradiction with a fact. A fact can be the given information, a postulate, a theorem, a corollary, etc. Number 4, the assumption, blah blah blah, whatever you assumed in step 1, the negation of what you need to prove, is false. And number 5, therefore, written with the symbol of 3 dots, as shown here, what you need to prove is true. Let's do an example. Prove that the bases of a trapezoid have unequal lengths. Given trapezoid ABCD, prove DC, segment DC, is not equal to segment AB. And this trapezoid ABCD is shown here. Whoops, my fault. They're not segments actually, because DC and AB are referring to the lengths that are not equal. So it's just DC is not equal to AB. Sorry about that. So how do we start this indirect proof? So the first step is to assume the negation of what you need to prove. And what we need to prove is that DC is not equal to AB. So then we must assume that DC is equal to AB. So step 1 is assume DC is equal to AB. Now, based on our given information, we know that ABCD is a trapezoid. So, by the definition of a trapezoid, we know that DC is parallel, that segment DC is parallel segment AB. Alright, so DC is parallel AB, segment DC is parallel segment AB by the definition of a trapezoid. And now there is a theorem, I don't know if you remember, which says that if a quadrilateral has a pair of opposite sides that are both congruent and parallel, then it is a parallelogram. So we have that DC is equal to AB, our assumption, and that DC is parallel to AB based on the fact that, on the given information, that that ABCD is a trapezoid. So DC is equal to AB and DC is parallel to AB, and by that theorem, that means that the quadrilateral is a parallelogram. So now we can conclude that ABCD is a parallelogram. So ABCD is a parallelogram because if a quadrilateral has a pair of opposite sides that are both congruent and parallel, then the quadrilateral is a parallelogram. But have you noticed a little bit of a contradiction here? We've concluded that ABCD is a parallelogram, but our given information tells us that ABCD is a trapezoid. You've just found your contradiction. So ABCD is a parallelogram contradicts that ABCD is a trapezoid according to the given information. And now that we've found a contradiction with a fact for our assumption, the assumption is false. So now we can say the assumption DC equals AB is false. And if DC equals AB is false, then DC is not equal to AB. So step number 5, therefore DC is not equal to AB. And we have just proved it. So if you guys were wondering, then for step number 2, which is getting conclusions based on the assumption, why it has multiple steps inside it. So for step number 2, you can have multiple steps within it or a few steps within it, depending on the problem. Step number 2 is the only step that can have or contain steps within it. Let's do another example to help you get a hang of writing an indirect proof. Given segment OJ congruent to segment OK, and segment JE is not congruent to segment KE. Prove ray OE does not bisect angle JOK. So our first step would be to assume temporarily the negation of what we have to prove. We have to prove that ray OE does not bisect angle JOK. So the negation of that would be that ray OE does bisect angle JOK. So we have to assume that ray OE bisects angle JOK. Our second step is to draw conclusions based on this assumption. So now if ray OE bisects angle JOK, then by the definition of angle bisector, angle 1 should be congruent to angle 2. So that's our next step. So angle 1 is congruent to angle 2 by the definition of angle bisector. And we already have that segment OJ is congruent to segment OK based on our given information. And then, by the reflexive property, we can say that segment OE is congruent to itself, segment OE, by the reflexive property. Now, if you look here, then you have segment angle 1 congruent angle 2, segment OJ congruent segment OK, and we also have segment OE congruent to segment OE. Now, if you notice, angle 1 and angle 2 are included angles. So, we can prove triangle OJE and OKE congruent by the SAS postulate. Once we have proved the triangles congruent, now, by CPC-TC, or congruent parts of congruent triangles are congruent, we can say that segment JE is congruent to segment KE by CPC-TC. Do you notice a little discrepancy here? Yes, because in the given information, we know that segment JE is not congruent to segment KE, but here our conclusion says that segment JE is congruent to segment KE. We have just found our contradiction. And once we have this contradiction, now we know that the assumption that we made is false. And once we know the assumption is false, we easily get into step 5. Therefore, ray OE does not bisect angle JOK. So therefore, ray OE does not bisect angle JOK. And voila! You just proved a statement using an indirect proof. See, it wasn't that complicated after all. Great. I hope you enjoyed learning how to write indirect proofs. Thank you.